All right, everybody, we made it to the final page. I'm going to be going kind of quick, so if at any time you need to pause this video, pause it. There's a lot of stuff, so I have to go quick. And it's Friday, right? Or it's going to be Friday, depending on when you watch this. So let's get on with it. Okay, I am going to look at this function right up here, and I'm going to be substituting 3 in for x and 2 in for y. And this is what it's going to look like. 3 in for x and 2 in for y. So let me get my marker here. And 4 times 3 is 12, 3 times 2 is 6, and 12 minus 6, 6 equals 6. That is a good check. All right, let's look at the next one. We are substituting -3 and -2 in the same function. 4 times -3 is -12. -3 times -2 is a +6. And that gets you -6 equals +6. That is a no. That is a no-go. All right, next one. We are substituting 0 in for x and 2 in for y. 4 times 0 is 0. -3 times 2 is -6. Again, -6 does not equal +6. That is a no. No-go, whatever you want to do. X's, no's. Okay, next one. We are substituting 2 in for x, 0 in for y. 4 times 2 is 8, and 3 times 0, 0 is the ultimate cancellation machine. 8 does not equal 6. That is a no. That is an X. Whatever way you look at it, it's no. Okay, next one. We are substituting 1.5 and 0 in. 1.5 times 4 is 6, and there's that cancel. 3 times 0 is 0. 6 equals 6. Hooray! That is a good check. Okay, number 6, 7, 8. You are solving the equation for y. Remember, we want to get y isolated, so we need to get rid of this x term. So I'm going to add 4x to both sides. And you get y equals 4x plus 16. 16 plus 4x is the same thing, but we'd like to have our x term first. Okay, next one. How do I get y all by itself? All I have to do is divide each term by -3. And watch, the negatives and the 3's cancel, and I get y equals -x or -1x. It's the same thing. But here, a negative divided by a negative is a +3. So don't forget about that +3. All right, this guy's a little trickier. We have to subtract 2x first from both sides. Shoot, cancels. I get -4y equals -2x plus 12. Now I'm going to divide each term by -4. And I get y equals -2 divided by 4, -4 is 1/2 x, and 12 divided by -4 is a -3. So you get 1/2 x minus 3. Next page for me. All right, we're going to graph each equation. Remember, the 3 easiest numbers usually to use when you're graphing is 0, 1, 2. So 0, 1, 2. If I substitute a 0 in here, 0 minus 3 is -3. If I substitute a 1 in, 1 minus 3 is -2. And if I substitute a 2 in, 2 minus 3 is -1. So this is what my graph would look like. You can see there's 0, -3. There's 1, -2, and there's 2, -1. And I could use a ton, actually an infinite amount of coordinates, and they would fall on that line. So how many solutions does that line have? Infinite. We could use an infinite amount of dots. Okay, next one. This was a tricky one. Y equals -1. Where's the x? Nobody knows. But what we're going to say for a fact is we know that y is always -1. And there's only one place where y is always -1. It is right here. It is a horizontal line. And if you want to help yourself, you can put any value in for x. All right, but it's 0, -1, 1, -1, 2, -1. It's just going to be a horizontal line going through -1. Y is always equal -1. That was tricky. All right, number 11. Before I show you the graph, I'm actually going to make this a little easier on myself. I'm going to solve for y. You didn't have to do this, but if you solve for y, you only have to do this once. You get y equals -4x minus 3. And now when I substitute 0 in, 0 is the ultimate canceller. It cancels that. 0 times -4 is 0, and I get -3. I'm going to substitute 1 in. 1 times -4 is -4 minus 3. You get -7. Really, you only need 2 points to graph a line. The only reason why I like to use 3 points is just to make sure that we did the other 2 correctly. All right. So -4 times 2 is -8. -8 minus 3 is -11. So let's see if we're right. I got 0, -3. I got 1, -7, and 2, -11 wouldn't fall in the graph, you know? So in that case, if I want to do a third one, I wouldn't use this one. I might say, well, let's use -1. If I put -1 in there, I get 4 times -4 times -1, which is 4, and 4 minus 3 is actually a positive 1. So sometimes the points you choose might not fall in the graph. All right, next page for me. 12, you are using this function and you're substituting these numbers in for x to figure out what y is. So let's do that real quick. With the power of the computer, we're going to go fast. Bang, bang, bang. I'm substituting in -2. Here I get -8. Minus 5 is -13. Here I get 4 minus 5 is -1. And 16 minus 5, which is 11. All right, number 13, I'm going to substitute these 3 numbers in for this function for x. Bang, bang, bang. -2 times -2 is positive 4. -2 times 1 is -2. And -2 times 4 is -8. All right, bang, bang, bang. We are substituting in these 3 for this x. 2 times -2 is -4, minus 1 is -5. I feel like one of those auctioneers. Just a lot of numbers really fast. 2 times 1 is 2, minus 1 is 1, and 2 times 4 is 8, 8 minus 1 is 7. So those are those guys, and writing them all as ordered pairs, okay? And the last one, 7 minus 3x, bang, bang, bang. Let's substituting -2, 1, and 4 in for x. Be careful here, -3 times -2, that's a positive 6. 7 plus 6 is 13. Some of you will get that wrong because you forget about one of those negatives. Next one. Remember, you're multiplying first. -3 times 1 is -3. 7 minus 3 is 4. And -3 times 4 is -12. 7 minus 12 is -5. Okay, so any questions on those? I can't answer any questions, so if you have any questions, pause it, chat. All right, next section. All right, you had to do the same thing for these. Substituting in, boom, boom, boom. All right, I'm going to go quick. 4 minus 2 is 2. 4 plus 1 is 5, and 4 plus 4 is 8. Those are your 3 ordered pairs. Bang, bang, bang. Careful, some of you will miss one of these negatives. A negative times negative is a positive. 2 plus 32 is 34. 32 minus 1 is 31, because that's a -1, right? And 32 minus 4 is 28. Okay, next section. We're dealing with a fraction here. 1/4 of -2. Okay, I'm going to look at that like this. It's 1/4 times -2. And I get -2/4, or -1/2. So if I get -1/2, 6 minus 1/2 is 5.5 there. Okay, 1/4 of 1, I know that, that's just 1/4, right? Anything times 1 is itself. So plus 6 is 6 1/4, or 6.25. And the last one, 1/4 of 4, that's just 1. 1 plus 6 is 7. All right, final section, timesing by 3/5, the hardest. All right, so 3/5 times -2 is -6/5, which is -1 1/5. Minus 6, you add the negatives to get -7 1/5. All right, here we go. Anything times 1 is itself, so 3/5 minus 6. This is tricky because I want to start on 6. I'm going to do this down here, 6. And when I subtract 3/5, I'm actually going to get 5 2/5, but I have more negatives left over, so it's going to be -5 2/5. And the last one, 4 times 3 is 12/5, or 2 2/5. All right, minus 6. So I'm going to reverse this problem. I'm going to say 6 minus 2 2/5. I'm going to subtract 2, and then I'm going to subtract 2/5 more. So 6, 5, 4, and then I got to subtract 2/5 more. So that's going to be 3 3/5. That was a little tricky. All right, and there's all the answers. If you want to pause it and look at all of them collectively together, because I was going kind of fast, you can see all your answers right here for 12 through 19. Okay, next page, graph the equations. The easiest numbers to pick are 0, 1, and 2. 0, 1, and 2. 0, 1, 2. When I substitute 0 in, I get 3. When I substitute 1 in, I get 4. And when I substitute 2 in, I get 5. So those are my 3 points, and that's what my line looks like. All right. Now, the problem is with substituting 0, 1, 2 here, watch. I get 0, I get negative 10, negative 9, negative 8. Those won't fit on my graph. My graph's not big enough because my graphs only go up to 7, right? So I'm going to pick a number a little higher, maybe like 5. 5 minus 10. 5 minus 10 is negative 5. If I pick 6 minus 10, I get negative 4. And 7 minus 10 is negative 3. And that'll fit on my graph way down there. Okay, you might have not thought it would fit, but it does. All right, and the last one, I'm going to substitute 0, 1, 2. 2 times 0 is 0, minus 1 is negative 1. If I substitute 1, 2 times 1 is 2, minus 1 is 1. And 2 times 2 is 4, minus 1 is 3. So that's what that graph looks like. All right. And again, if I'm going fast, pause it, check it. All right, next 3. Here, if I use 0, that's always good. 0 cancels, I'm going to get negative 6. But if I pick 1, 1 times a half is a half, and I don't want to deal with halves. So this is where we're going to work smart, and I'm going to use the number 2, because half of 2 is just 1. And I'd rather do 1 minus 6 than a half minus 6. So 1 minus 6 is negative 5. Gotta love the whole numbers. And the next number I'm going to use is 4. I'm going to stick with evens, because half of 4 is 2. 2 minus 6 is negative 4, and this is what that graph looks like. You're way down there. Okay, next one. I'm going to substitute 0. 0 times negative 3 is 0 plus 7, and I hope you realize why we're using 0. It just cancels the x term. All right, I'm going to use 1. 1 times negative 3 is negative 3 plus 7 is 4. And 2. Negative 3 times 2 is negative 6. Negative 6 plus 7 is 1. All right, so that's what this graph looks like. And finally, we see this one again. Remember that? Y equals negative 6. You got to remember, just y is always negative 6. And where is y always negative 6? It's a horizontal line through negative 6. And finally, for the last 2, let's substitute 0, 1, 2. All right, when I substitute 0 in, I get negative 2. When I substitute 1 in, I get negative 1 minus 2. Remember, add the negatives. And when I substitute 2 in, negative 2 minus 2 is negative 4. This is what that graph looks like. And finally, to make my life easier, because this is a tricky problem, I'm going to solve for y. And watch what happens. I'm going to get y equals negative 3 halves x. Now, I want to pick a number to substitute here that's going to give me a whole number. So if I pick 0, that's good. If I pick 0, I'm going to get 0 equals 0. That's nice. All right, my origin is going to be a point. But if I pick 1, I'm going to have a fraction. What number could I put here to cancel that 2? 2. When I put the 2 in there, the 2's cancel. So when I put 2 in as my input, I get negative 3 as my output. Guess what I'm going to get when I put 4 in? Let's put 4 right here. That's going to cancel and get 2. Negative 3 times 2 is negative 6. And check out this pattern. Go down by 3, down by 3, up by 2, up by 2. All right? And that's going to be important later. But when you plot those 3 points, whoa, almost broke something back there. That's what that graph's going to look like. So we are going fast, guys. If you have any questions, please ask. That took a lot of time for you, I'm sure, but it's going to teach you how to be a better algebra student, and there's a much quicker way that you're going to appreciate after substituting. You'll never have to use random numbers again. All right, but you got to know why it works. So, guys, enjoy the weekend, and miss working with you guys, and I hope everybody's well. Have a good weekend. The weather's getting warm, and enjoy it. All right, see you guys.